Hello, statistics student. This video is for chapter 1.1, part 3. We are looking at two concepts here. Just review a percent decimal calculation and also talk about what is a good sample, because to have a good prediction using the sample data to predict about population, your sample needs to be good, right? Your sample needs to be representative. So we'll talk about how to get good sample, which is what we'll be doing in 1.2. So it's kind of like an introduction of that. So first, some percent and decimal calculation. Why are we doing that? Because when we collect data that describe a category or characteristics, sometimes we want to find out what percentage belongs to that category, like what percentage of students are male, female, what percentage of students live in a certain city, etc. So when we are counting how many belongs to some category, we would like to use percentage to represent them. So first is how to convert between decimal and percentage. So a decimal number such as 0.75 would be 75% because you can move the decimal point two places as if you are dividing it by 100. Right? So if I have a decimal number of 0.0178, I move two places or actually multiply by 100. So that would be 1.78%. Basically, what you do is you change 0.75 into a percent that has 100. So because anything that is over 100 is a percent, right? So if you did multiply something by 100, that's moving the decimal point points two places, right? And that is the meaning of a percent. Any fraction that has 100 is a percent. So that is that's the meaning. But in the shortcut, we will just move places. Percent to decimal. So if you have a percent number like 25%, you want to get it back to a decimal, so you would move it back, right? So this is the decimal point at the end of the number. You move it back, it will be 0.25. You, of course, when you write it, you would take the percentage off. Sometimes a percentage had a decimal number in it. So when we say decimal, we mean decimal with no percentage in it. So this is still a percentage. It's still a percentage, but with a decimal percent, less than 1%. So to convert that, we move 1, 2. So you would have to add 1 0. So that's why they have 2 0, 0.001. 4% is 0.04 because the decimal point is at 4, and then you do 1, 2, so you add 1 0 over here. How do I find percent? Percent is actually a representation of a fraction. So you describe how many parts is it out of the whole. So the count of the category over the total data would be a percentage. Okay, when it is represented in decimal form, we call it a proportion, and we can change it into percentage to find percent. For example, I think earlier we say, okay, out of 45 students, I didn't have an example here. 23 are female. So what percentage are female? So we know this is the part and that is the whole, right? So all the student in your sample, so the percent would be 23 over 45. You use a calculator to do. You divide 23 by 45, and it's 0.511 like that, and change into percent. So maybe we'll just use the 2 decimal points, so it will be 51%. We'll talk about rounding in 1.2. For the time being, they would just do whole number. Usually in a question, they would tell you what to round to. And if you don't say anything, you give the exact value. What about find percentage of amounts? So 6% of something. So if you know your percentage, and this is the whole number, so what you do is you multiply. you change the 6% into a decimal, and then you multiply by the whole. Okay, 6% of 1200. Sometimes we feel like 6% of 1200 should be smaller, right? So we feel that we need to divide because we wanted to have a smaller number. But actually 6% is a small number. If you change in the decimal and you multiply it by decimal, it's actually smaller. So it is a multiplication. So whenever you say a percentage of something, you multiply. So if I put in the calculator, 0.06 times 1200 is 72. And then 12% of 2418, maybe 2418 students or something, then you do 0.12, you change into decimal, and then you multiply it. So it's 290.16. So now the exact value of 12% of 2418 is 290.16. No rounding, exact value. But if this is about adults, person, then you just do 290 adults. Okay, just do normal rounding. So some people would say, well, Miss Chen, if it's 290.9, if I do like other percentage, should I just still say 290 because still less than a person? When we do calculation, you will do normal rounding. You say 291. Okay, so it's just normal rounding. Normal rounding means if it's more than 5, you round up. 5 or more, you round up from the next digit. We'll talk more about this in the next section. Okay, so that is percentage and decimal. Going back to a sample. So if we are doing inferential statistics, we use sample data to want to do some prediction. Our sample must be representative, right? A sample should have the same characteristic as the population it is representing, so that statistical value calculated from the sample can be used to estimate the population parameter. So, when is it good to say a sample is unbiased? And when is it say that the sample is not representative? So in general, I think I have a general guideline here. Here. Oh, no. Where did it go? I think we have a general guideline saying that the sample needs to be, for it to be representative, the size needs to be not too small, right? It'd be substantial size, not small. So you can't just say, oh, I'm going to collect 3% and then use it to estimate the population. That's too little. And then also it has to be random. You have to, when you pick your sample, it has to go through random selection. So what is a good random selection arrangement? It is not just mindlessly pick someone. So random generator. Random number generator? Yeah. Okay. No, not this one. So if you say random number generator, so what happened is if you have, yeah. So this is a online random number generator. You just Google random number generator and it will show up. So suppose you know your list of all the numbers or all the subjects in your population. So in our case, say for example, we have 40 students. I say my target population is 40. I'm going to select a few students. So I would say from 1 to 40, pick me a number, give me a number. So 18 is what I randomly selected. Give me another one, 14. Okay. So using some kind of random generator to generate the number that you are supposed to collect, that is random selection. You distance yourself from making any choice, making any, because when we do our selection is usually not random. So use a random process. Of course, you can put all the names in a head and then draw them. Okay. For example, a fitness center interviewed 15 of its customers on how much time they exercise per week. Can the result be used to estimate the average time of all the customers per week? What do you think? It depends on how many customers they have. I would say no, because 15 customer is too small, right? It's low. the size is low. And also, we don't know if it is a random selection. So maybe they select it by asking the 15 customers that comes earliest, right? The second one, an online survey invite users to rate a new design of a certain shoes. Want to check if a particular shoes is appealing to customers, so they invite users to rate them. Can the result be used to predict the preference of all customers? So again, they're using a sample to predict, right? So they want to make sure that the people that actually do the survey are representative. Would an online survey result in random? Not random. So this kind of samples are actually we call voluntary sample. People come to the website, you invite them, but they have to make a decision to, or they visit your website and then they have to decide to participate. This is called voluntary response sample, and usually they are biased. Why? Because people that interested in it have strong feelings about maybe they like this shoe, they like shoes, or they don't like the shoes. So you end up, ignoring a lot of customers that are indifferent to it, or too busy or whatever. So voluntary response samples are not representative. Okay, so in a nutshell, the easiest way you can evaluate if a sample is good or not is, are they voluntary response sample? Do you select the sample through a random process? Do the researcher, actively select it through a random process? And also, if the number of subjects in the sample too low. So that is all of chapter 1.1, and you can use this to do your worksheet.